Imagine solving a LeetCode problem using just one line of code. No heavy math, no complex prime algorithm, just pure bit manipulation power. Today we're solving LeetCode 762 prime number of set bits. And I'll show you the trick that most people completely miss. We're given two numbers, left and right. For every number in that range, we convert it to binary. Count the number of ones. Then ask one question: is that count prime? Now here's the insight. The maximum number of set bits for any number up to 10 to the 6 is just 20. That means we don't need a full prime checker. We hardcode the prime bit mask and let bit shifting do the rest. One expression, 0 loops for primes, O of one prime check. That's the power of understanding constraints. Not brute force, not memorization, precision. Let's build it. Let's look at an example. 6110, 2 set bits, 2 is prime. 7111, 3 set bits, 3 is prime. 81000, 1 set bit, not prime. Our job? Count how many numbers satisfy this condition. Now here's the elite insight. The maximum value of right is 10 to the power of 6, and 10 to the 6 in binary is about 20 bits long. That means the maximum number of set bits any number can possibly have is 20. So we only need to know which numbers from 0 to 20 are prime. That's it. No prime checking loop, no square roots, no extra function, just constraint awareness and bit power. Prime numbers less than or equal to 20, 2, 3, 5, 7, 11, 13, 17, 19. So instead of checking if something is prime every single time, we store them in a set. Constant time lookup, no computation, no overhead. For every number in the range, we count its set bits. Then we simply ask, is that count inside our set? If yes, increment. If not, move on. Clean, efficient, intentional. No prime function, just constraint mastery. That's great problem solving. Class solution. Define function. Count prime set bits. Takes 2 parameters, left and right. First, create a set called prime set. 2, 3, 5, 7, 11, 13, 17, 19. Initialize count to 0 for each number in range, left to right plus 1. Check if number.bit count is in prime set. If true, increment count by 1. After the loop, return count. Clean logic. Constant time prime lookup. Linear scan. Efficient. Elegant. Elite. Why is this powerful? Bit count runs in constant time. Big O of 1. Checking membership inside a set also runs in constant time. Big O of 1. The loop runs at most 10 to the power of 4 times. So the total complexity, big O of n. Super clean, super fast, interview safe. And if you really want to flex in interviews or contests, you can solve the entire problem in one line. That's not just coding. That's understanding constraints. That's mastery. Class solution. Define function count prime set bits. And now the one-line flex. Return sum of open parenthesis 1 left shift number.bit count close parenthesis and 665772 greater than 0 for number in range left to right plus 1. Here's what's happening. Number.bit count gives the number of set bits. 1 left shift creates a mask at that exact position. We compare it with 665772, the prime bit mask. If the result is greater than 0, the count was prime. No sets, no prime function, just pure bit engineering. Clean, fast, interview dominant. That number, 665772, is just a bit mask with prime positions turned on. Competitive programming level. Unlocked. If an interviewer asks why this works, you say, since the maximum number of set bits is bounded by 20, we pre-compute prime numbers up to 20. For each number, we count set bits and check membership in constant time. Overall time complexity, big O of n. Space complexity, big O of 1. Clean, confident, done. If this helped you understand bit manipulation better, subscribe for daily, elite, LeetCode breakdowns. Next video, we solve a problem using a trick even FAANG candidates struggle with. See you in the next one.